I have a battleship. And I have doubts about the Eclipse.
Hello and welcome to the Hackaday podcast. I'm Elliot Williams.
And I'm Tom Nardi.
This is episode 266, a writer's deck, patching your battleship, and fact-checking the Eclipse. Hackaday Europe is, well, if you're listening to this now, it's probably starting tonight. We're probably going out for our pre-party this evening, if this is Friday and you're listening to this. And if you have waited until Saturday morning to listen to the podcast, we're already started.
The future is now.
I wish I knew if we were going to be able to get streaming up and running, but that's going to work out last minute. So if you want to check to see if we're streaming any of this, head on over to hackaday.com on Saturday morning, and we'll put up a sticky post if we are able to get everything online after all.
I mean, it wouldn't be a hacker convention if there wasn't a little bit of last-minute madness, right? Well, I'm still jealous. I'll be stuck stateside, so for my own benefit, I hope there's going to be a live stream, but at the very least, we'll have recordings, right? That'll be cool.
Even if no live stream, we're definitely recording it, and we'll get those videos out to you soon.
And I've already got my badge, so I have the play-at-home kit.
Although your badge doesn't say Berlin on it.
I know. I can get a sticker. I'll get like a sticker and a Sharpie or something. But no, I mean, I was looking at the schedule of the talks and the workshops. It's really going to be awesome. I think, at this point, people know if it's going to be a Hackaday event, it's going to be something special. But it bears repeating that there's going to be some phenomenal demos and talks and workshops, and it's a lot, if for effectively one day, right? Because, Friday and Sunday are just kind of hangouts for the most part. So get your rest early.
It's 2 days. I don't know. It's a day and a half at the very least. Sunday's a good day of lightning talks. And, it's kind of mellow. It's low key, but it's also, I love the lightning talks because you get everybody up there giving distilled their best 7-minute talk, one after the other, just bam, bam, bam. And that's actually kind of really fun. I wouldn't say I like lightning talks more than the official regular talks, but kind of a limited scope that you can talk about in a 7-minute talk too, right? But still, usually people pack more into the 7 minutes than they do 7 minutes of a regular talk.
Yeah, I mean, it's great at SuperCon this year that we were able to do that last year, I guess. But yeah, it's really, like you said, it's very, very dynamic. And, you have some people who maybe they didn't even have an idea until they got there.
That's right.
When somebody else, at the event does say, hey, wait a minute, I think we got a lightning talk here.
Part of the fun is to just walk around and say, hey, that's really awesome. Do you want to give a lightning talk? And people are like, yeah.
Yeah, I think it was very literally like picking names out of a hat, right? Like, yeah, right?
No, it was literally walking around in the alley being like, hey, you want to give a lightning talk?
Now, usually, for the record, if you're in an alleyway and somebody approaches you about giving a lightning talk, you might want to be, wary, but at SuperCon, it's okay.
Yeah, anyway, can't wait. By the time you're hearing this, it's already on. So you're either there or you're not. If you want to follow along in spirit, head on over to Hackaday.
This is a journey into sound.
What's that sound?
What's that sound?
Should we head on over to What's That Sound?
Oh, God. The bane of my existence, yes.
No, I have faith in you on this one.
Let me listen here. No pressure. No pressure. I would say it's very Zelda-ish, right? Or certainly, or like Star Fox, maybe one of those.
Do you care to take another guess?
Let me listen again.
Listen again. Christina listened to it twice.
Damn, that's not like Link to the Past on Super Nintendo?
Nope.
No, I don't know. I'm beat then.
Oh no, that's horrible. It is Final Fantasy VII.
I've never been a huge Final Fantasy guy.
Me neither, honestly.
Yeah.
The truth of the matter is my wife was looking through her old video game consoles and found, God, I think it's a Nintendo DS, the dual screen one from like 2000, and she has Final Fantasy 3 on it and is playing through that again. That would have been too obscure, so I went Final Fantasy 7.
I imagine we had many right answers this time.
Oh, we did. We got 74 answers. Well, but there are a couple duplicates. Some people entered twice, but you're not fooling me.
In their excitement, they answered twice.
Yeah, probably. But we got that. So let's say we had a few duplicates. So maybe 68. Yeah, of them, like 64 are correct. There were only a few wrong answers thrown in, and they were pretty close to right. I mean, Super Mario Brothers was a popular wrong answer. That was twice. Getting item sound from one of the Legend of Zelda games was a totally good guess. And best wrong guess of all is Chrono Trigger, which is...
Got Square, too, right?
That was the game that came out right before Final Fantasy, I think. So that's pretty solid. That's a good, solid wrong guess.
It definitely sounds a lot like the, you have found something Zelda one, too.
It does. It does. That's not wrong. Everybody else was like Final Fantasy 7. And, half of people's names were like Chocobo and One Winged Angel. And there's a ton of Final Fantasy 7 fans here.
Shocking.
Truly
shocking.
Bunch of video game nerds. Let me see. I got to find a random number generator. This one's going to be lousy. All right, I'm doing my random image one again.
So you can load it with a Final Fantasy themed image.
Oh wait, I could do a hash of the Final Fantasy music. Actually, that's what I'm going to do. I'm going to do a hash of that music file. Good.
Oh wow, this is a great idea. How come we haven't thought of this before?
How come we haven't done this every time? Exactly. What? All right. No such file. Okay, that's because I do this every time.
I think no such file has won previously.
No such file won a couple of weeks ago. But this week, it's number 37. And number 37 is Vinyl Ecstasy. Congratulations. Final Fantasy VII Victory Fanfare. You got it. I'll get in touch with you, get you a Hackaday podcast t-shirt. Everyone else, thanks for playing along. Good job, y'all. And next week, we'll come up with another sound that if you get right, you can stand a chance at winning a Hackaday podcast t-shirt. All right, my first hack this week is from John Shone of Proper Printing, and this is 3D printer hot off the griddle. This is a strange and interesting 3D printer design of his, the TIME, the Truly Independent Multiple Extruder Printer. And this thing is really long. It's got a Y dimension of about a meter or so. And he constructed this out of a grill plate. Then he had to flatten it, so he actually had to screw some aluminum extrusion on there to hold the thing flat. So it's a really long Y-axis. And along this, it's got two linear rails. And on these linear rails run independent XZ gantries, and there are two of them. So it's got two kind of entire 3D printers, basically, sharing a really long print bed. It's not an original idea. We've actually seen one of these. There was a prototype of one done by Autodesk's Project Escher, which I think had 5 print heads or something.
Yeah, something like that, yeah. 4 or 5.
But 2 seems actually like a more reasonable number to me because you can get one of them out of the way and then the other one has access to the whole print bed and vice versa. So it kind of doesn't overcomplicate figuring out the task planning and how to maneuver things around problem in quite the same way that having 5 heads would. But still, it gives you some flexibility. You can do multi-materials without all the waste of changing out different color filaments and purge towers and all that mess. So I think that's kind of cool. The XZ gantries are entirely custom. He actually makes them out of 3D printed trusses that are then held in tension by, I think, Kevlar string or something. I mean, this is a really strange custom system, but it aims to make the XZ gantries really lightweight so that they can move around quickly because, of course, they do have to travel back and forth. And the fact that he's doing them with kind of Core XY, but here I guess it's Core XZ topology, lets him place the motors really low on the gantries so that they don't have the balance wobble problems that they might otherwise if they had a higher center of gravity. So that's kind of interesting. I mean, there's all sorts of crazy out-of-the-box thinking going on here. He's not done with it yet. I mean, he's got the thing kind of up and running, but doing the path planning, doing the slicing for it is not completely solved yet. And My guess is that he's going to continue improving on this basic idea for quite a while. But it does give you a couple really neat advantages, and that is it's got a really long y-axis. So at least in one direction, you can print things that are, looks like about a meter long. Really, you could print a guitar neck or something. And then at the same time, it's got two of these gantries. So you can do two material, multi-material prints fairly easily with low overhead and complication. Actually seems like a really nice kind of, I'm not going to say it's a simple solution, but compared to some of the other tricks that people do to get multi-material working, like putting two heads on the same x-axis so that they're kind of in the way of each other, or like tool swapping, which is probably, if you have more than two materials, tool swapping heads is probably the only way to go. But that adds a degree of complexity that is not to be underestimated. So here, I think just slap two movable gantries on it. It's like a bed slinger, only it's a gantry slinger, and both of them move.
Well, yeah, I think that's exactly it, right? We're seeing Prusa is going all in on tool changing for the XL, and that's great. But like you said, there is a lot of complication there, and linking up the new tool head and making sure everything's aligned, and the alternate would be feeding different filaments into the same extruder, which Bruce has also tried, and the other companies are doing, but that has its own problems and it's prone to jamming. And it's kind of like, well, the easiest thing would be just to have almost a whole duplicate printer, right? Because that's understood, and the parts are super cheap at this point. What's it? Steppers, a hot end, and an extruder. You pick up the extra hassle in, like you said, the moving of it and the software side. But even that, I mean, it's not an unsolvable problem, right? And you simplify so much of it on the other side that it's really just, I would say, it comes down to, do you have the space to do two gantries like this? Like if you're trying to do something compact, then you're kind of stuck with some kind of switcheroo and the downsides of that. But if you got the space and a big hot plate to work on, sure, why not just duplicate the printer and run it like that? It kind of has some of the benefits of like the belt printers that we've seen, like the Infinite Z kind of stuff. But very few things actually need Infinite Z. People have done huge swords and stuff like that as kind of like a gimmick. But I think for most things that are too big for a normal print bed, your standard 250 millimeter by 250 or whatever, this is certainly gonna get you there. If you had something like you said, like a guitar neck or frame for a quadcopter or something that's longer, then you could get into it. This would get you there, right? So you don't need necessarily all the complication of the conveyor belt and all that stuff just to get something significantly bigger than the normal printer.
Yeah, and I think he's planning to extend this in a bunch of different ways. It's funny you mentioned the infinite belt one, and one of the gimmicks there is that they usually incline the XZ axis at 45 degrees so that it can print, on an incline, and then it rolls along. And he's actually got allowances in this for one of the heads to be offset at 45 degrees. So he can come in on the side and print, which might help with overhangs. He didn't say that in the video, but I guess he's actually planning on that. The other thing is the path planning here is actually really simple in the sense that he really just clicks one extruder in and the other out. And, the only thing that you need to do there is you need to kind of calibrate the Y offset for both of them. And then you need to, minus sign the Y terms, right? You need to have it move in the opposite orientation. But that's really it. And so I think in a lot of ways, this is kind of the minimally different from normal 3D printing solution. And that's kind of what you were getting at. And I totally agree. The other thing that's weird, though, is that this is that by using a Core XY, except up on its side, so it's a Core XZ, the Z direction is now not on a slow lead screw like with a normal 3D printer, but it's on a fast direct drive stepper driven thing. And so in principle, the Z is going to move as fast as the X axis is. And so that also is going to let him do non-planar 3D printing in a better way in the future. And I think he's probably got plans there. So I think this one machine looks like it's a test bed for 3 or 4 different ideas simultaneously. And I think he's going to be hammering on it on a bunch of different fronts. So it looks like it's going to be a lot of fun for him to just play around with a bunch of crazy 3D printing ideas. So I would say stay tuned to this guy's YouTube channel.
Well, my first pick this week, talk about, bespoke ways of doing something that we thought was a solved problem. From Uncoolee, it is a writer deck, which is kind of a spin-off of the cyber deck phenomenon that we've seen a lot of over the last couple of years, in that you have people making very, very customized, bespoke, drilled down to the absolute minimum kind of computers. Except the writer deck is taking that a step farther. That all you're going to do on it is writing. Some people may say that would be a pen and a pad, and I suppose you could do it that way. But this is the high tech version of that, where you have a keyboard, a display, and just enough computational oomph to get those things to link up with each other. The project we're covering here is like the 4th version. It's gone through a couple different generations, and each one, is kind of fascinating in its own way. Especially like the first few, what is a cyber deck is kind of a debate for another time. But the first 2 would certainly have qualified as cyber decks. Let's say we were running a competition for cyber decks.
Right.
I think these first, the earlier ones would absolutely have fit in. You got your wide aspect screen and your mechanical keyboard and your weird faux 80s kind of layout, and there you are. But those were based on the Raspberry Pi, or I think in one case like an Android phone, and they were all still a little bit too heavy for what the goal was. The goal was just like, I got a burst of inspiration, let me knock this out. I don't want to wait for anything to boot. I don't want to look at a loading screen. So this final one now is actually using the ESP32, a custom text editor written for this purpose. Like I said, it's a step above the pen and the pad. It is a hand-wired minimalist keyboard. You enter text and it comes up on the screen, and that's pretty much all you have. There's very little in terms of fluff. Let's call it that way, right? Like the idea is to be distraction free. So there is nothing to distract you. There's no music player. There's no news feed. There's, and even though you could, the ESP32 is hardly being taxed with such a simple application. You certainly could add a little bit of flair in there, but this just keeps it as simple as possible. You grab it, it's ready to go in an instant. You knock out your, whether it's a Hackaday post or the next great novel, and you're done. And you can turn it off and put it back on the bedside or whatever. The only kind of maybe luxury here, and calling it a luxury is probably the wrong thing, because you can see how useful it would be, is that he's worked in Google Drive syncing. So you can knock out a few paragraphs, and it just pops up to the cloud, where presumably you'll grab it from a slightly more capable device down the line. So that's really cool. Otherwise you're shuttling SD cards back and forth, or you're fiddling with USB cables. So I think having that, taking advantage of the Wi-Fi on the ESP to have kind of a seamless cloud sync is really cool. As much as I am generally distrustful of of the cloud, I do see the advantage here. And, it's got battery power, 18650 cell and the usual suspects there to get it all working. I mean, this is definitely something that everything is here for you if you wanted to recreate it. But I do think that might be missing the point a little bit. I think, you still want to bring your own personal kind of flair to it and your own style to it. But this is certainly an excellent basis to work from if you're looking for some kind of a little digital companion to journal your life, or maybe talk about all the cool things you see at Hackaday Europe coming up very soon.
If you put a cheap camera in it, then you'd really have something like one of those like cheesy little cameras. Then it could be like you could take the pictures at the same time. That might be really interesting. No, it's such a cool device, and I like the form factor. I like the size. Like, it uses a 30 key keyboard, right? Or it can't be only 30 keys. Well, but
I think
yes,
so.
it is.
Yeah.
It is only 30 keys. So it's, it's going to involve some chording and some shifts and stuff, but you can get used to that. But it makes it just incredibly small, and it's got one of those little TFT screens and an SD card. Like, I don't even want to guess how long the thing would run on that
Oh yeah.
18650 cell. I mean, it's
Yeah.
you certainly get a day out of it.
Easily.
That's all right. And then, like you said, you can sync it up when you get back in Wi-Fi range. That's just a crazy cool idea, and something to bring around with you, throw it in your backpack, type on it whenever you want.
A personal blogging companion where you could maybe take pictures and type out an article and just kind of keep it, to that minimal, distraction free, low effort kind of way of getting your thoughts out and documenting things. I mean, that'd be cool too, actually, for like project documentation, something you could just like, knock some notes out. And
yeah, that's why I was thinking a cheap camera, because then it turns it into like a portable lab notebook or something.
Yeah, that's really cool. We actually, for anyone's curious, there is actually like an API for Hackaday IO to push notes and pictures into it. So you could maybe tie it into that. That would be pretty cool. You could
directly
go right
into
from
your IO page.
Yeah,
oh, that's good.
So I think there's a lot of potential for this kind of a format. And like you said, in terms of battery life, I mean, the Pi versions probably got a respectable battery life, a couple hours, but you're talking a microcontroller, even if you didn't go serious with like the sleep modes. I mean, it could run forever, on a decent sized 18650, especially if you're not, you're only syncing once in a while. I think there's a lot of potential here. I'm excited to see more development along these lines, which is, I think, made possible by the fact that we have these cheap, powerful Wi-Fi enabled microcontrollers, right?
Keeping on the crazy keyboard devices tip, I've got Daniel Beardsmore a write-up of a brief history of keyboard encoding. Now, this is really cool because it's a deep dive into computer keyboards at the very early beginnings of computers at all. And there's some crazy ideas here. And I think to understand it, if you've ever put together a keyboard yourself, basically you just have a whole bunch of switches and a whole bunch of diodes to keep them from backfeeding through. And then you put them in a matrix and you scan it with a microcontroller of your choice, rows and columns, and boom, you're done, right? You could tell which switches are being pushed. But imagine, if you will, long enough back in time that these diodes were expensive and the computers of the time didn't want to spend all their time just polling the keyboard. How would you make an electronic computer keyboard? And that was kind of the point of this article, and that's what I thought was neat. One of the ones that I didn't even think of was this, and we have a little featured image of this in the article, was a photoelectric encoder. It's got 8 light and photocell pairs, and each of these can be interrupted or not by a kind of a comb thing that's attached to each key. So when you press the key down, it blocks a few of the lights, but not all the lights, and the pattern that makes it through tells you which key is pressed. And that sounds great. You could even, if you cut the slots just right, you could make it give out ASCII straight away. That would be awesome. Except you can only press one key at a time. Because, of course, if you press another one, it's going to block all of the lights and, it's going to mess up. And that aspect of kind of getting the ability to press multiple keys at a time works itself out through a whole bunch of these earlier designs as well. There's a crazy set of switches made by a company called Microswitch, which I thought microswitches were a thing, but apparently there's also a company called Microswitch. And these have multiple little reed switches in them, and you can pull them out or put them in depending on what value you want the thing to kind of output in binary when you press the button down on the switch. So in this version, every switch has 8 pins out or whatever, and it makes the contacts internally, a lot like that crazy comb device did, breaking the light beams, except this one is internal to each switch. And then eventually, I guess, diodes got cheap enough that they have a diode equivalent version of this where it has a pull-up and then it activates a bunch of different lines. So like here, all the switches would have a bus of basically 8 wires going to each switch. And internally to each switch was the encoding about which lines would get pulled high and which would get pulled low. That's crazy too. And of course has the same rollover problems. The solution to that was to make even more elaborate mechanical switches that only momentarily pulse all of these lines. So if you press like F and A at the same time, as long as it's not exactly the same time, you'll get the pulse out for A and the pulse out for F. Of course, there's no way to hold the key down. So they had to have a special like repeat key that you could also press down at the same time if you wanted to like, hold down the F key and have it press a bunch of Fs. Crazy stuff. There are keys here that use mercury switches. There are keys here that use mechanical switches. There are keys that use ferrite cores to encode the, what particular key is being pressed signal in them. Really strange, really bizarre history of how you could make keyboards work before they kind of settled on this modern scanned matrix with diodes system, which is just so easy in comparison.
Well, that's the big takeaway, right? It's just so easy, that when you look back at these, they seem almost comical in how complex they are, But at the time, hey, this was what you had, and this was state of the art. And it reminds me, looking through the page, it reminds me like core memory. That today it's like they were doing what? they wove the wire, and then they you can only look you when you read it, erased it. Like it seems it's hard for us to even imagine working within these constraints because we're so jaded basically with modern technology and high performance microcontrollers that can do this stuff in the blink of an eye. It's to the point where I don't know that there's anything you can learn necessarily from this. It's almost like you look at like a cave drawing and it's very impressive, but it's not going to help me, use Inkscape, right? Like it's a very different thing, and you can appreciate it, but I don't know that there's much to take from it other than appreciating what we have and appreciating, the way things developed the way they did. I mean, it's fascinating. I mean, it's definitely something to look at and to learn, how we crawled before we could walk, right?
Yeah.
But I don't. And again, to use that core memory example, we've seen modern recreations of core memory, and they're really cool from a kind of educational standpoint, but no one's going to use it in a modern project, right? So it's cool to see what could have been maybe, or maybe the best way to look at it is these are the things not to do because we've done those and they worked okay, but we found a better way. So probably don't go down that path. I am digging the photoelectric one. I almost want to see somebody do that because it is pretty cool. Like you're talking about, like the way the shutter could be done, so that you're getting a full 8 bits per key press. So it's
right.
That's really clever. That's like something like the paperclip computer where it's like so basic that it's brilliant in its simplicity. And I could imagine doing something like the front panel for some 8-bit computer or something where like each key is an opcode or something like that. You can just press it and just knock it in directly as 8 bits. That'd be kind of cool.
It has to be like this labyrinth of switchy, switch things on the inside.
I want to see the Mike Gardy recreation of this. He's always good for taking these almost pre-computers and recreating them with 3D printing and other modern technology. And I'd love to see his take on something like this. Just do like a macro pad that's done like this. All right, I had to pick this next one. I don't know if it's the child in me or the father in me, but I think both of them are in love with this project. This one came from David Barrett, and it is a story of finding a one of these ride-on kids electric Jeeps on the side of the road and saying, hey, I think there's some potential there, right? I would say that, it got a new coat of paint, but I don't think it actually got any visual changes. It still looks kind of like the day it was on the side of the road, but what it did get was a whole new electrical system, which is arguably more interesting to folks like us anyway, right? The battery was shot, and frankly, the what passes for electronics in one of these things is pretty minimal in the first place. It's just the throttle is a momentary button, and the direction is a switch that just changes the polarity going to the motor. So all that went out. All that went out the window. And in its place is 18-volt system, which is getting provided by Ryobi tool batteries. So right off the bat, you have a much lighter battery. You have a standard that's easily swappable, right? So the kids can keep running for longer and less downtime. But, it wouldn't be enough just to wire the 18 volts to the motors, at least not for very long. So David also put in a proper motor controller and an actual, analog throttle pedal. And there's regulators to step the 18 volts down to 12, because apparently there are lights and little, doodads and stuff on there that did still need that 12-volt power. And all of that could have been done in sort of, the quote-unquote dumb way, right? What I really liked on this project is that into the mix he adds an ESP32, and it's kind of sitting between the kid and the motor controller. And it lets him do a lot of cool stuff. He talks about in the article where, like, he has two children, one much older than the other. So the younger kid gets the slower speeds and the more gentle acceleration curve, whereas the older kid, can have a little higher top end and a little more punch from zero. The ESP has Wi-Fi, of course, like we were just talking about with the writer deck, so why not use it, right? So then he's kind of whipped up this web interface that lets him, check the battery voltage and set these speeds and change the curves for the max speed, but it also gives him like a big red emergency stop button, right? So if he's out there with his kids and they're zipping around and they're getting too close to the street or something, boom, he hits the button and remotely disables the motors. So it's a really cool project where, it kind of strikes me as you almost wonder if somebody at, Wearer Power Wheels is looking at this article and like, damn, why didn't we think of this? Why didn't we do this? And, I would not be surprised if this isn't already on like some of the high end ones, if it doesn't start coming out now, because it is really a very clever idea where you could have these kind of like tunable performance things and absolutely that emergency stop. Anybody who's, got a little one that's careening headlong into danger would love to be able to just, stop them in their tracks, right? So I think it's a really cool project, and there are so many of these ride-on things. This is, like I said, this is a Jeep Wrangler for at least externally, right? So there's a lot of variability in like what's going to be under the plastic hood of your particular child's car. So it's not the kind of thing where you could have like a one size fits all necessarily. But I think David did do an excellent job here of documenting it to the point that it'll get you in the right direction. It might not be 100%, but it'll get you like 90%. He's got the source code for the ESP, and he's got some wiring diagrams, and he's even got a bill of material for like, what the throttle pedal he used and like the direction stick and that kind of thing. So, even though it's not a maybe the turnkey project that we've seen, before where you can just, hey, go out immediately and duplicate it, I think this is a great start. And I hope that it kind of inspires other people to, if you see one of these things on the side of the road and you got some kids at home, or if you're looking for your own, small mode of transportation, this would be one of those projects that you look at as kind of inspiration and kind of give you a path forward.
I love that the comments took the, you should be putting a real gasoline engine in it turn. There's actually the first 15 comments are absolutely hilarious. And of course it escalates to jet assisted takeoff. So, in a Barbie Jeep, right? So, yeah. Well, bringing up the rear for me, a vibratory rock tumbler bounces on printed spring. And this is another interesting mechanical device by France. And this one is a take on a rock tumbler, which, as Tom, who wrote this, points out, could be as simple as just a jar on a roller that, rolls over and tumbles the rocks around. Except this is not that simple. This one has a very strong electromagnet that shakes the jar that contains the rock and the polishing medium up and around. But as France very interestingly demonstrates in this video, it's not enough to just shake things back and forth because they don't move around. You actually kind of have to scoop and throw. And getting this scoop and throw mechanism out of a 3D printed device is what I thought was super cool here. And to do that, he's got to have two different shaped 3D printed springs, basically. And so he's got one spring that allows it to only move back and forth in the horizontal dimension, and then another spring that's kind of horseshoe shaped that lets it go up, down, and left, right. And so when the magnet hits, of course, it's got more degrees of freedom in this one, and so it kind of scoops around and it makes this rotating circle, whereas the other one just goes back and forth, and it ends up making a kind of a scoop and throw motion out of the simple, just fire this electromagnet as an impetus. And I really, really like that. And that's what's really cool here. We featured a bunch of Franz's videos. They're all absolutely marvelous mechanical devices that he ends up mostly 3D printing. He'd done one of those vibratory spur staircase things, climbing up and around the spirally stairs. By the end of it, he's got multiple versions, one more elaborate than the next, and some of the 3D printed parts get replaced by printed metal parts, and the whole thing gets screwed down to a cement block to make it quieter. Most everything is FDM printed, but in the end he subs out a clear SLA printed container for it so you can watch the rocks go around, and that's actually really sweet too. So, you could do this on the simplest, or you could refine it as much as he has by the end of it, and that's pretty cool too. As always, all his designs are open. You can just make it as is, or you could just use it as inspiration for your own designs. I've always wanted a rock tumbler. I guess, Tom, when you wrote this, you assumed that we'd already had one, and
yeah, I did. I figured that was like a rite of passage.
Man, I totally want one, and I love that you say if this were Rockaday, we might go further down this particular rabbit hole and explain the pros and cons of each machine. And as the member of Hackaday who didn't have a rock tumbler, I kind of wish you did. Tell me about Rockaday.
Yeah. I smell an article here, right? But he actually does kind of talk about the difference between the rotational one and vibratory, and like the Cliff Note Rockaday version is like the rotational one. The rocks, or I didn't have to. You could be doing parts or something there too if you want to clean up whatever. But let's say rocks for the sake of argument. The rocks like really beat into each other, and it tends to smooth them out more than you might want. They kind of take on this rounded thing, this shape, and you kind of lose that definition that you might have had. Whereas like the vibratory one, it's more of they shimmy around in the polishing stuff, so you get a shine on them, but you don't necessarily lose like the edge details. So like the vibratory ones are better for finish work, whereas you do the rotational for the bulk, that sort of thing. So obviously any rock polisher worth their polished rocks would have to have both for the ideal. Naturally. No, this is a really cool project, and it's funny, when I was writing it up, like I wasn't sure. I mean, ultimately I did describe them as springs, but it is kind of weird to describe these printed parts as springs, so they certainly don't look. It's almost like a leaf spring in that it's just a big flat bent thing, but these aren't, they. If I had one on the table, the last thing you'd think was a spring. In fact, you might think it's like a toboggan or something, that shape on it. But yeah, it's really cool, and I gotta say that the clear printed chamber is just phenomenal. Like when I first saw it, I was sure that was a glass jar, and I 3D printed in clear resin at JLC, and it reminded me actually. I don't know if you saw at SuperCon, Joey Castillo had an open book that he had the case printed in the same clear resin, and it was just incredible. It looks like it's like glass that they have formed into whatever shape your mind can create. So if you're looking for that particular superpower, it has arrived. I don't know exactly how much it costs, but if you ever want like that transparent aluminum from Star Trek, we're pretty close.
And you can prototype it with a regular 3D printer, because at the end of the day,
exactly.
You just ship out the files. And I think that's what's really cool here too, is that he prototypes it in regular old PLA. Actually, then he has an SLA printer of his own, and he prototypes it in black SLA, and then he just ships it out to get the clear one. And yeah, that's awesome. Really cool. Can't wait to see what his next project's going to be.
Yeah, I figured we all had rock tumblers.
Yeah, right? Who didn't have a
doesn't have
rock tumbler? Man, looking at some of those pictures at the end, I need a rock tumbler. Those are some shiny ass rocks.
These are the prettiest rocks I ever saw.
Yep, I want each and every one of them.
Well, for my last one, this is a shocking abuse of authority. Not only did I write this one up, I picked it to talk about on the podcast because it interests me a lot. So, sorry, not sorry. This is how to properly patch your Iowa-class battleship, and this is about Battleship New Jersey, which is one of the Iowa-class battleships that was laid down for World War II, but continued to serve into the 90s because, hey, if you're going to spend all that money on a battleship, you might as well get the most use you can out of it, right? It's currently in for maintenance. It was last out of the water 30-odd years ago, and now we have the wonderful, technology of YouTube and high-definition cameras and people with time on their hands. So the process of, hauling it out of the water and inspecting the hull and treating the rust and looking at the way they patched up things over the years is all being, documented in. It's funny, and I'm guilty of this myself. I kind of belittle YouTube maybe more than I should because so much of it is kind of fleeting and playing to the algorithm and just nonsense. But then you have stuff like this. This is historical documentation. This is important stuff. This is something that's being preserved, and the methods are being recorded for others to use. They talk a lot about that they learned a lot of what they're doing from the Battleship Texas that had a similar kind of dry docking period a few years back, and by virtue of the ability to record everything they were doing in high definition and do all that kind of stuff, there's now like this blueprint for, okay, well, how do you preserve a steel ship that's pushing 100 years old? What are the do's and don'ts and that kind of thing? And instead of being locked up in some archive, it's available for all of us to look at, so it's certainly not everyone's cup of tea, but I find it fascinating to look at all this kind of stuff. And, the Battleship New Jersey specifically has an excellent YouTube channel that was kind of born of COVID, right? It's an active museum. And when COVID happened, they couldn't do tours. It was, imagine trying to do social distancing inside of a battleship, right? So tours were out of the question. So they switched over to doing a lot of virtual stuff, and they went all in on YouTube. And the curator, Ryan Zemansky, is just really good at describing weird, in-depth stuff on a warship, and the YouTube channel is filled with just all kinds of weirdo stuff, things you would never be able to see otherwise or know about. How does the analog firing computer work, and what is that involved in, and if the primary bridge is damaged, where do you go to steer it? And he takes you down there and you see this stuff and things that haven't been seen in some cases since World War II. They've been locked up in the bowels of this behemoth ship, right? So I think it's really cool that this kind of information is out there, freely available, and admittedly, we don't all have our own battleships to take care of at home, so it's maybe not directly applicable to our day-to-day lives, but I do think it's really cool from a historical standpoint, an educational standpoint, and in the case of this ship particularly, I think it's amazing that it was, I think, laid down in 38, 39 or something, and here we are in 2024, and it's still floating and still being worked on, and it's kind of like this living record of the state of the art for any given time. It was refit several times for the battlefield of whatever era it was in. So you started with these analog computers just hurling 16-inch chunks of steel at stuff, and then by the 80s that had been replaced with computers and cruise missiles and potentially even like nuclear weapons, although the Navy has this weird thing where they don't confirm nor deny what ships actually had nukes on them. So it's seen it all, right? And to have all that kind of documented is I think very, very interesting.
Yeah, and like you say, if you're thinking of buying a battleship, you're going to want to test the hull for leaks before you buy it, right? So, there's some of these tricks are totally useful.
Yeah, it's how they nickel and dime you. You get a good deal on the battleship, but then it needs all kinds of work.
there's this one scene where they're pressurizing the hull and then spraying all around this patch with soap and water mix to see if it bubbles out, which is pretty fun. You know, maybe that's a take home. If
Yeah, you
you've
could do that
never
one.
tested for air leaks with soapy water, maybe that's a take home that you could use on, I don't know, bike tire tubes instead of battleships. My first quick hack comes from Sebastian at Baltic Lab. This is a spark gap transmitter characterized. And this is really cool because he's actually taking an oscilloscope to and measuring stuff about a spark gap transmitter. And my first reaction was some of these scope traces look remarkably sinusoidal, like it's a damped sinusoid. And that's because he's actually built an LC tank circuit here to the thing so that it actually resonates at a given frequency. And he's able to hit his 3 megahertz target basically spot on, but then confirms what I was afraid of, which is that spark gap transmitters are horribly, horribly noisy. And he plots out the spectrum and it's got about 15 dB of signal to noise ratio. This thing is, yeah, I mean, there's some coming out at 3 megahertz, but there's a lot of spit as well. Anyway, cool to see that brought out with modern equipment and not just guessed at. Next up, emergency dip pin repair for anyone is a sweet little hack by Zafar Yildiz. He goes at an 8-pin dip that's missing one of its 8 legs with a Dremel tool deep enough that he can get down to the die, puts it in a socket, and then solders to the socket pin from there. Of course, then he plugs it into yet another socket, so it's kind of got 2 sockets on it. It's just a reminder that inside that plastic or ceramic package, there's a lead frame that you can get to if one of the pins falls off. And last up, a drone motor does e-bikes by ProKnow. This is kind of a silly hack. He says, you know, I've got this 500 watt drone motor. Maybe I could gear it up so that it could run a bicycle. 2 things are wrong with this. One, a 500 watt drone motor is meant to be air cooled by fast moving propeller air. And second, it's only 500 watts of electrical input, not 500 watts of power. And third, getting this gear ratio is insanely difficult. And that, I think, is where this video kind of ends. I mean, he's got it going around in circles, but you can hear the gears going crunch in the background.
All right, my first quick hack this week is the easy way to make a smart appliance. I think we get knocked sometimes, probably rightfully, for, you know, maybe having hacks that are bordering on what you can fairly call a hack, right? We have some of these things that are, you know, multi-year projects that cost untold amount of money to, you know, put together. And sometimes it's nice to just see like an old school legit hack, something that's simple and didn't take a, you know, garage full of machining equipment to put together. And this is definitely in that camp. This is making a rice cooker automated by using an energy monitoring smart plug. There you go. The product is done. At least on the hardware side, that's done. The real hack here is the software, right? And being able to talk to the monitoring plug and putting a little logic in there and tying it into the larger home automation system. In this case, Terrence Eden is using some code to detect when the energy use of the rice cooker goes down, a sure sign that the rice has been cooked, right? And then sending off a notification and, of course, being able to power off the device. You're able to get a lot of this, you know, modern smart home nicety with your existing gadgets with little more than, you know, open source projects and some glue code. So a very cool little weekend project to put together if you'd like to have internet connected rice. Next up is double checking NASA's eclipse estimate at home. In case you weren't aware, there was an eclipse over the United States a couple days ago. Most of us saw clouds, or we saw a slight covering of the sun, but if you're lucky enough, you saw something closer to a proper eclipse, and Bob Badley was decently close. He got, according to NASA's estimate, an 87% coverage, which is not too bad. he got to hang out with some friends at the local hackerspace, and they looked at it through all the appropriate non-eye cooking gear, and that was fun. But the real fun was when he got to go home and check out his home photovoltaic solar system, and he was able to compare the panel's output with the estimates that NASA had released in terms of when the eclipse would start, when it would peak, when it would end, when the coverage, how much the coverage would be, and so on. And he found, unsurprisingly, that NASA is really good at their jobs, and they were able to predict the start and end of the eclipse down to a couple minutes. Maybe even more interestingly, the coverage figure that the NASA estimator gave him was almost exactly how much the power was reduced by his solar setup. So if you were ever worried that NASA's just making it up as they go along, this is a good reminder that they kind of know their stuff. And from one comparison to another, my last quick hack is comparing desoldering tools. For those of you like myself who've been limping along with the Radio Shack iron with the rubber bulb on the back of it, the proper desoldering guns have actual suction and are way better, but are very expensive. So in this video, go head to head with a Hacko model and a Dora tool. Won't go blow for blow here, but the end result is that the cheap one is not as good, surprise, surprise, but it's probably not 4 times as bad as the more expensive version, if that makes sense. If it's something you're going to use occasionally, it's probably fine to get the no name. And if you're doing this professionally, you probably shouldn't be taking advice from a YouTube video anyway.
That brings us to our Can't Miss articles. These are long-form pieces written by our fantastic Hackaday writing staff. This week I got Al Williams's In a Twist, Humans Take Jobs from AI. And this was inspired by the closing down of Amazon's Just Walk Out shopping system, where they had cameras track you around in the store. You had an identifier on your cell phone that would then bill you for everything you took when you walked out automatically. And of course, it was all done with AI and, automatic vision recognition and so on. And part of the reason they're canceling the program is that it turns out that when they shut it down, they revealed that about 70% of the transactions required human interaction, which means that this whole AI program had, 1,000 people behind it. And this turns out to be consistent with a lot of AI ventures. Al mentions it in this write-up that, for instance, there is a company called Presto that wanted to do automatic drive-through order taking for a restaurant. I think they got a contract with Carl's Jr., but they also had to feed off whatever the AI couldn't handle to people, remote workers in the Philippines. And their failure rate was about 70% here, which means that the AI was handling about a third of the orders. Similarly, on the virtual assistant front, Facebook put out one called Facebook Messenger. That one also had extensive human intervention. A competitor, Wit AI, same thing. And again, about 30% of user requests were actually handled by the AI, and the rest were handled by people. Al's point here is that this isn't very strange, and in fact, this is kind of what Mechanical Turk was doing, although they were admitting to do it, whereas now I guess nobody is admitting that their AI is actually run by people 70% of the time in the background. Anyway, I think it's an interesting sense of where the state of play on these kind of human-serving AI systems are, that by and large, most of them end up failing over to people 70% of the time. And this did remind me also of the self-checkout debacle. And Al also wrote this up a few months back. Ask Hackaday, why are self-checkouts failing? And this is because a lot of grocery stores that use self-checkouts have discovered that they end up spending so much employee time having someone, every time there's a red flag, they go over and they help the customer with their checkout. And it ends up being slower, or they end up having dead or blocked self-checkout things because this one cashier assistant is having to run around between all of them. And the systems are expensive to begin with and maybe don't make as much sense as you thought. So I think it's interesting to look at all of these together as we are kind of hurtling into this world where, we're being sold this idea that these systems can take over from people, whereas it looks like something like 70% of the time there's actually a person behind it. Whether this is a bad sample, because these are all the firms that failed. Your AI plan fails if it has to be backed up by humans 70% of the time, or what, I'm not 100% sure. So, I mean, that's also possible. Is outsourcing to AI more palatable to the end consumer than outsourcing to third world countries? Are we just like outsource washing with this AI? Hackaday wants to know.
I don't know if we want to know.
I think Hackaday doesn't want to mention that.
Yeah,
I think Hackaday wants to back that one up again.
Yeah. I think we're terrified of the answer. I thought this one was kind of funny. This is sort of a tangent, if you'll allow me, but it was funny. This one brings up Mechanical Turk, which I haven't thought of in years. But I remember when it started, I guess in the early 2000s, we were gaming this thing all the time. And I remember there was like, Python scripts you could download and like browser plugins that would just hammer at the little tasks they gave you. And, thinking back on it, I don't even know if the responses it was providing were gibberish or what, but Amazon was paying for it. You would run this script and you'd just watch the little Amazon money tick, 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 tick. And youthful days, I had this running on a few computers and they were cranking out money. It was like crypto before we knew what that was. And, they'd pay you in Amazon bucks or whatever. So, me and all my friends, we'd be buying, monitors and all kinds of like computer stuff with this, money that was just out of thin air. We just had our computers cranking all day, generating this Amazon Turk money. And the thing that was always funny to me at the time was, the whole idea was like, oh, well, we created Amazon Turk because these are tasks that the computers can't do, but mine sure as hell was doing it. I don't know how well it was doing it, but it was doing it good enough to pass whatever rudimentary check. I think it was like identifying album covers or something. Like it'd be like, is this a Metallica album or something? And it would rip through these things at inhuman speeds. And I always thought it was funny that nobody at the Amazon hive mind thought that was weird that I was identifying, 10,000 album covers in an afternoon. But yeah, whatever. Having said that, it's that was probably 20-ish years ago when they first, this early 2000s when they introduced this, and it seems like things have only gotten slightly better because we're still struggling to draw that line between, what's AI and what's just a person pretending to be AI to make some money. I don't know. I think that there are applications for this in like customer service and that kind of thing. I was actually interested in Google's offering where they would like wait on the phone for you, if you want to like make reservations and that kind of thing. Because I often go to such fancy restaurants that require reservations. But it would it'd hold for you and then be like, oh, I want to get a table for two or whatever. I think there are interactions like that are I don't want to call it simple enough, but I suppose predictable enough, right? Like if you're making reservations for a restaurant, they're probably not going to ask you what your favorite color is. They're going to say, what time, how many people, thank you. Right. So I think stuff like that's easy. But then when, if you're trying to take somebody's Carl Jr.'s order, that's way, way harder. I mean, it might seem simple on paper, right? Like I want a hamburger, but no. I would invite anyone who thinks that's a simple problem to go to a restaurant with my wife and have her order a hamburger because it's not going to be just a hamburger. The top bun has to be rotated 30 degrees in relation to the bottom one, and it can't have, seen the moonlight. Like she has such specific. I mean, I won't even order for her, and I'm a fully functioning human, so I could imagine why an AI wouldn't want to do it either, right? So I think once you got people into the mix there's just too much variability, and I'm not surprised that they're saying as much as 70% of interactions had to fall back on a real person, because there's probably 70% of people are just that difficult to deal with in day-to-day conversations.
Mechanical Turk is kind of the opposite, right? It's here's things that we wish we could solve by AI, and we're shipping them out to humans. Here's how humans can make money doing this. At the same time, there's the current AI craze is we're going to replace all humans, but then in the end, they need to have the humans to do the backup. And it does make me think in both of these cases that there must be a better way to do it, where you use the AI systems to help the people do their work better and more efficiently. And like this whole kind of try to replace the people with an AI system is maybe wrong-headed. You probably want to make the AI system so that it helps the people do their jobs better, right? And I think that's a direction that we will see a lot of in the future. And I don't think that, I mean, people get into the AI debate in these comments, for instance, and someone mentions AlphaFold, which is this protein folding neural network algorithm behemoth, right? And it's absolutely fantastic. And if you listen to molecular biologists telling you what they can do with this, it's a tremendously useful tool for them, because it's a neural network trained on a bazillion patterns of proteins and how they kind of configure themselves in physical space. And of course, it's not always right, and you have to know what you're talking about, and you have to know how to guide it, and et cetera, et cetera. The same sort of thing appears with these large language models. But at the same time, it's an incredibly invaluable tool when used in the hands of PhD molecular biologists, right? And so I think that's kind of what I want to see out of AI in the future, and these sort of things is I want to see it used as a human enabling technology. I want to see it making the people's work better, rather than this kind of myth where they're like, oh, we're going to get rid of all the people, and then they're like, oh, okay, but we 70% of the time need the people after all. It seems like that's an inefficient way to arrange it if you're going to admit, and that admitting it was a tool rather than a replacement might be the better way to go.
Less robot overlords and more robot coworkers.
Exactly.
Takeaway, right?
Exactly. Thank you.
Well, for my can't miss pick, I had to give this one to Aria, and the latest entry in just a fantastic series on lithium ion power. Personally, and I would hazard to guess I'm not alone in this, which is why she started the series. I kind of looked at a lot of these lithium packs as spooky danger inside of a spicy pillow, and that there was a lot of ways for things to go wrong, and that maybe I'll just stick with the double A's, thank you, because I don't want to burn my house down. And don't get me wrong, there is danger, right? I mean, these are dangerous things if incorrectly used, but her series of posts has been extremely illuminating, I think, in showing that it doesn't have to be so scary, and that we can do this with affordable parts and open source code in some cases, and maybe above all else, just knowledge, right? Know what you're doing and know what not to do. And this latest one talks about, the different pack configurations, which, I know that if you're in like the RC hobby or whatever, like they throw these numbers around. I'm doing a 3S, whatever, blah, blah, blah. And if you're not up on that, what does that mean? What's a 3S? I don't know. What is it? And so she starts off with talking about what that is, how it's one is the serial, how many batteries in serial versus how many in parallel. And, using that combination, you build up, you say you need, 11 volts, right? So each battery is 3 volts, and then, 3 of them get you to 11 and change. And that's where you want to be, but you need more capacity, so then you'd add more packs of 3 cells in parallel, and you kind of run the numbers to get the capacity and the voltage as close to your ideal as possible. Invariably, you're going to probably need to regulate in some direction anyway, but you want to try to get to a logical point, right, physically. So she talks a lot about how that works, and sort of best practices there. I mean, these aren't, you don't have to be completely Wild West here. There's sort of expectations. If you're looking to do something off 5 volts versus 12, there's an accepted way of doing this stuff, and you don't have to start from scratch. And then, that kind of leads directly into then, okay, so now you got, 16 individual 18650 cells, and they're in whatever arbitrary arrangement. How do you safely charge them? And like more specifically, how do you balance them? Which is the idea that you really want all the individual cells in the pack to be, roughly the same voltage, as closely as possible. And that's actually a little bit trickier than you might think, and sort of the failure mode that I think is maybe the most common in a pack. It's one cell kind of gets out of alignment with the others, and the onboard circuitry is like, well, I don't know what to do. One of these cells is a half a volt off, and I'm done with this. And that kind of leads into where you'll get these battery packs that just kind of give up the ghost, but actually are 90% good. They just have one cell that's out of whack and needs to be brought back into the fold. Talks about the kind of modules that are on the market. You don't have to reinvent the wheel here. This is the kind of thing that's so ridiculously common now that they have the modules on the market, and they're insanely cheap. I've been kind of following along with a lot of her articles in this series, because it's something I've been interested in. And she name drops some of these modules, and you'll go on the usual suspects, AliExpress, and it's like, here's 50 for $1, and it's unbelievable how cheap some of these things are. But then you remember they're in everything. They're in everything. I mean, they're literally disposable. They're, for better or for worse, right? These rechargeable packs are getting tossed in the garbage every day. I mean, there's her whole series has been really, really good. I think this one is particularly important because it does talk about, like I said, making the packs and balancing them, which is where it gets a little bit, dark magic-y. But on the whole, if you're following along, it really does demystify the lithium ion. And, we talk a lot about, these superpowers, right? That the modern hobbyist has, like being able to send away and have stuff made out of translucent, materials. This is a sort of a similar thing. I mean, this is what the big boys are playing with, right? I mean, inside an electric car, there are just, thousands and thousands of these same cells that you could use to power your own project, using the same kind of principles and best practices. So it's really cool to bring that down to our level, but do it, safely, and making sure all the loopholes are taken into account. So highly recommended if you've ever wanted to play around with this and do battery powered stuff, but you're leery about it, you're worried about burning your house down, or follow along, maybe take some notes, and you'll get there in the end.
Like you, I've been screwing around with harvesting lithium ion batteries, and like you say, it's the number of battery packs where it's like one bad cell is shocking. And it is because what happens is that one cell gets low, it's got a little more resistance, and then it just keeps getting hammered every time you charge it back up and discharge it. If you're doing this kind of stupid serial charging where you put the same current through all the cells, that one battery is getting the short end of the charging stick, and then it discharges more as well, and it's just getting hammered repeatedly. Whereas you can get around a lot of this by balance charging, as she suggests. And so that kind of makes sure that all the cells are up to the same level. And even when you have a less than perfectly balanced pack, if you're balance charging it, you stand a chance of having it last longer than if you're just doing simple serial charging. I can do nothing more than second what she says about getting balancers and, BMSs, battery management systems, to do all the balance charging for you. The other option, and she doesn't mention that here, is this is done a lot in the RC world. It's also a useful trick to know, is you can just run wires out from all of the battery terminals so that you can access each individual cell individually. And then there exist balance chargers that do this for you. And so there's kind of a standard pin header in the RC world where if you have like a 5S or a 6S pack, and these are pretty standard size, so it's 6 batteries in parallel, it'll have 7 wires, so one for the ground and then one for each intermediate battery, and you can charge up each of the cells simultaneously in parallel with one of these balancing chargers, and that does the hard work for you. The interesting thing there is you can get like a balance charger for like $20, and that will work then with all of your battery packs. Whereas if you have to put a 10S, 6S, BMS into everything, that's $4 each. And so, if you're building a lot of these battery packs, maybe it's cheaper to go with a balance charger and just a bunch of wires. Whereas if you're building just a few battery packs, you probably want the BMS on board and the simplicity of having it do the balancing for you. I don't know. There's two ways to go there. I've been doing a lot of hoverboard hacks, vehicle for my son, and still experimental and dangerous self-balancing robot for myself. Both of those battery packs are run on a balance charger, and they're 10 series, but it's easy enough to get a balance charger that'll do 5 in series. And so I just have 2 of those, and I plug it up to each half of the same battery and charge it up. And that brings the whole charge up nicely in about an hour and a bit. And I think I bought the balance chargers for like $20. Not much outlay. Really cool. Gets my hoverboard batteries charged up safely. And so far, so good. I mean, so far they've been running under, reasonably high load and high output conditions for a year and a half without giving me any trouble. So, I don't know. One data point. You're welcome. That wraps it up for this week's Hackaday podcast. Thanks very much for listening. To follow along with the links or leave comments, head on over to hackaday.com/podcast. And if you see anything cool or do anything cool, shoot us an email, tips@hackaday.com. And until next week,
keep on hacking.
All right, let's do this. Whatever. Madness.
Bah. That's the bloopers, just like a cut of bah, bah, bah. But you can auto-tune it into a song or something. Ooh, how is that possible? It says the one link, but then if I click it, it's the other one. Ooh, spooky. I feel like that's an exploit.
Freaking Google.